Powerful reasoning large language models like Fable and Opus tend to deliver better quality results, but they cost more tokens per request, plus additional reasoning tokens to use, and they can respond much slower than normal large language models. Smaller models, by comparison, are faster and cheaper, but can't perform complex reasoning tasks. In single agent architectures, there is a tendency to pick powerful models to essentially token max our way out of problems. However, since tokens are expensive, applying this logic to multiple agents within a multi-agent architecture will bankrupt you pretty quickly. Also, tasks that agents need to perform can vary in complexity, and using powerful models to perform simple tasks is counterproductive. This is where model routing comes into play. Model routing is a traffic system for AI that matches each user request to the appropriate model to serve that user request. In this video, we'll take a look at how routing works in Microsoft Foundry, how we can set up model routing, and how we can configure our agents to use model routers so they can choose the best model for the task that they've been given. But before we get started, if you're into .NET, Azure, and AI engineering tutorials, don't forget to like and subscribe for more content. Model routing acts as an automated decision-making layer that analyzes incoming tasks and directs them to the appropriate large language model. So instead of hard-coding every request to use an expensive high-end model like Fable, model routing will match the complexity of the task to the optimal large language model. Model routing is ideal in multi-agent architectures, as different tasks will fall into different complexity categories. Some tasks will be better served by being handled by models that are appropriate to the task that they are given, rather than just burning tokens to use powerful models for simple tasks. The complexity of each request is assessed by the model router before the models are invoked, and then the model router will decide which model matches the requirement of the request. Microsoft Foundry has a built-in model router, which is a trained machine learning model that analyzes each prompt in real time and routes it to the most appropriate large language model for the task, optimizing for cost, quality of response, and latency. Model Router is a machine learning model that's been trained on numerous scenarios, ranging from single prompts to complex agentic workflows. And Microsoft updates the active router version with new models and routing improvements, so you don't have to do that. Model Router will analyze prompts based on the complexity, reasoning, the task type, and other attributes. When Model Router is used with agents, it will analyze the full request context. This includes the system message, the user message, tool definitions, and conversation history. Model Router has 3 routing models for us to choose from. The first is Balanced. Balanced considers models within a small quality band, and then it will select the most cost-effective for that task. The second is Cost, which will use a larger quality range and then choose the cheapest or most cost-effective model for that particular task. And then finally we have Quality Mode, which just goes ahead and picks the highest rated model for the prompt and ignores the cost. Each turn in the conversation is routed, as the model router works, per request, not per session. During a conversation, you might have multiple agents using different models depending on the request. The router will determine the complexity of the request based on the following. So for factual recalls, a simple greeting, or basic follow-up questions, these requests are considered low complexity tasks and therefore will use cheaper models. Tool orchestration will route to mid-tier models to reliably generate structured tool calls at a lower cost. And then finally, research or multi-step reasoning and complex code generation tasks will route to the highly complex tasks, and therefore will be typically routed to higher performing, higher cost models. Setting up model routers in Microsoft Foundry is similar to creating a regular deployment. You can find it in the Foundry model catalog just by typing model router. The defaults will give us balanced mode across the full supported model set. You can also customize it if you need to use different routing modes or you want to restrict the subset of models to route to. So here are all the models that are available to it. So all of the GPT ones from OpenAI, Grok is there, DeepSeek, Llama, and then also these Claude models as well. The exception with Claude is you have to deploy these models first because some of these models are gated by your subscription type. So what you would do is you would create the Claude models that you want to include within the model subset, and then add that model to the model subset so your model router can include that particular model. So to create a model router in Bicep, it's pretty much the same as creating a normal model deployment. For our sample, which we'll talk about in a bit, we're going to use a triage agent to route to different agents depending on the task that it receives. The model router for each specialist agent will then select the underlying model. Now, in this Bicep block, we've implemented the cost routing mode so that simple tasks will be routed to agents using either the GPT 5.4 Nano or GPT 5 Nano models. And this is really handy when we want to further refine which models handle specific type of tasks. So if instead of just letting the model router just route to any old model, we can choose which models we want to be included within the model subset within our router. Now let's jump into our sample. Last year I got back into skateboarding just for a little bit of exercise and to do something different. It's not the safest midlife crisis ever, but we'll just roll with it. Imagine we have a multi-agentic system for a second-hand skateboarding gear marketplace, where skaters can buy second-hand gear from others instead of having to shell out hundreds of dollars to get a decent setup, and skateboards are quite expensive. So listings on a marketplace might look something like the following. So we've got a brand for our skateboard, a skateboard width in inches, length, wheelbase, what condition it's in, what the price is, the photo of an actual item, and that's attached to a seller ID. So who's actually selling it, how long they posted it, and also a description about the particular item. So to demonstrate the model routing concept, we can implement the following agents. So I have this buyer question, which will ask a question about the listing, and the agent will triage that to other agents as well. So I've got an agent for a spec agent, which essentially reads facts about a particular listing. Then I have a price agent, so if we're assessing how fair a particular price is for a particular item, this agent can help us do that. And then there's also a scam as well, because some of these sellers have very new accounts, they haven't completed any sales, some have open disputes, so because it's a second-hand marketplace, we can be susceptible to scams as well. So that agent is going to help us figure out which listings are scams and which aren't. And these agents are going to use different routing modes for different model routers. So for our cost one, for just basically getting an agent to answer or look up some basic facts, we're going to use cheaper models. So GPT 5.4 Nano, GPT 5 Nano, cheaper models to do simple tasks. For our price agent, we may have to do some tool calls. There may be a little bit of judgment there. So we're going to use balanced mode for our model router here. And that subset is going to be GPT-5 Mini or GPT 5.4 Mini. Some of these models you may be thinking might be quite limited in capability. I am somewhat limited by my subscription type. It's a benefit subscription that I've got through work. So I can't just go ahead and deploy Claude models, which is a bit of a shame. But for our scam agent, we're going to use quality mode routing, and that will route to models like GPT 5.5, GPT 5.4, etc. Okay, so let's see in the code how we're actually mapping our model routers. So within my Bicep deployment, I'll have particular outputs for different types of model routers. So I've got my router efficient, router balanced, and router frontier, even though they're not technically frontier models that I'm using, but they are higher end compared to the others. And I'm routing these, or mapping these, to particular roles. So one for our spec agent, one for the price agent, and one for the scam agent. So within my agents.py file, I've got this method here defined, so ensuring agents. So essentially, I'm just looping over the roles and specifications to go ahead and create those agents and map them to our model router deployments. Now, in the model parameter here, essentially you just provide your model router as a normal model. So you deploy model routers like normal model deployments, and then you also consume them with your agents like normal model deployments as well. So there's nothing special that we have to configure within our agent. We just call them like normal models. The triage agent down here also uses the efficient router as well. Again, it's just doing a simple task. It's just basically saying, okay, this is the question I've got, point that way. So we can configure it like so. And again, we're just calling our model router like any normal deployment. Now, to observe model routing decisions, each response includes the model field, which shows which model was selected by the router. So in this runner.py file, I've got this record method here. And essentially, we use that field to show which model was selected by the router. We can use that to track routing distribution across our agent's interactions. So I'll get off camera because we're going to buy a second-hand board. Right, so look at the following listing here, so L04. So this is a Santa Cruz Screaming Hand board. That design is pretty cool, and the price looks pretty good. So for $40, that sounds like a really good deal. But if we look at the description here, brand new sealed, price firm, and I had 3 others. Message me on WhatsApp, we can do a bank transfer. Don't bother with the app checkout, it's slow. And it's using a stock catalog image. So it does sound a little bit too good to be true. So I'm going to open up a terminal, and I've copy and pasted that in, but I'm just going to run this demo and put in that listing L04. Okay, so let's get some basic facts about the deck. So let's see, what width is this deck? So this is a simple question asking about a fact about the deck. So as we can see, the triage agent has taken our task and it's routed our request to the spec agent, which has gone ahead and used the GPT 5.4 Nano model. So this is just a basic question. Now let's go ahead and see if this $40 price is fair for this. Is this a fair price? Okay, so we can see that the triage agent has routed to the price agent, and that took 1.4 seconds, because that's a fairly simple task, and it used GPT 5.4 Nano. And then the price agent looked at that, used the GPT-5 Mini, so our request was routed to that model, and it's taken 10 seconds, and it has looked at used a tool, lookup comparables, and it's determined that no, $40 is far below market. It's looked at recently sold comparable boards, showing a median price of around $105 for a good condition Santa Cruz Screaming Hand board. And it said the listing has red flags, so there's using a stock photo, it's conflicting brand new sealed versus seller stated good, and then also a pressure to move payment off platform. So it could be bogus or a scam. So let's dive into this a little bit more. So we're going to go, is this seller dodgy? And there we go. So yes, this looks very dodgy. The listing uses a stock catalog image. The seller account is only 3 days old with 0 completed sales, no verified payment. And the description pushes us to use WhatsApp and a bank transfer off platform. And $40 AUD price for a brand new board or brand new Santa Cruz deck is also suspiciously low. So the verdict is a likely scam. So from a model routing perspective, we can see that the triage agent has taken our request and has used GPT-5 Nano to route it to our scam agent. And our scam agent has used GPT 5.5 to go ahead and assess if this seller looks dodgy, which it does. There is a little bit of a high overview of how model routing works for Foundry Agents, but hopefully you can understand how we can use model routing to route simple requests to cheaper models like we did when we asked what the width of this deck was. We were just looking up a basic fact, so we don't want to burn too many tokens on a large model to just do simple tasks. And then how we actually used larger models to perform more complex tasks. So assessing whether a seller was dodgy or not we need a higher level model to do that, so we could use the model router to actually route to GPT 5.5, which has that capability to do a little bit more reasoning compared to cheaper, smaller models. If you want to have a look at the complete sample for this, this is on my GitHub. So Will Valida is my GitHub handle. The repository is cost-effective multi-agents. I'm working on a couple of samples in here on how you can actually build cost-effective agents in multi-agentic architectures, and I'll pop a link to this in the video description below. Hopefully you now have a better understanding of how model routing works in Microsoft Foundry. You deploy it like any other model deployment, configure your agents to point at the model router, and the model router will select a model according to the configured mode and model subset. Let this be your sign to ease up on token spending when building your agents, and let easier tasks be handled by lower cost models. Models like Opus and Fable are powerful, and they are a lot of fun to use, but you need to use their power in its proper place. Thank you so much for watching. If you like this video, give it a like, and if you want to see more content on Azure AI agents, don't forget to subscribe. Any comments, pop them in the comment section below, and all resources will be provided as links in the video description. Thank you so much for joining me, and I'll see you all in the next one.